Papa Podcasts presents Students Teaching Students. My name is Kenny, and I will be teaching the topic of significant digits. I would like to start off with this example called significant donuts. Imagine there are two boxes of donuts. One box says 10 donuts for $1, and the other says 100 donuts for $10. But in each, one is missing. So there's only 9 in the 10 and 99 in the 100. With which box would you be more annoyed by? Of course it would be the one missing from the 10. But why? With both, you're only missing one donut, and you're still only missing 10 cents, but you'll miss the 1/10 more. Simply for the reason that 1 over 10 is 10%, and that is more than 1 over 100, which is 1%. Now, I also want to use the example used by teachers in school. Now, they use this example of measuring an object to relate to significant digits. So, let's say you're measuring an object and you're using a centimeter ruler, like the one on top. You can clearly say that it's between 3 and 4 centimeters, but you cannot say with certainty anything more than that, but you could say with relative accuracy that it is near halfway. And since it looks like it's less than halfway, you could say 3.4, and then you could say that that is your estimate. And both of those numbers would be significant because there would be a base and a reason for the choice of them. Now, if you use the millimeter ruler, you see that it is actually 3.4, and then you estimate the next decimal place, like 3.42 or 3.43, and those digits become significant. Now, onto basics. Significant digits are numbers that are deemed significant by a set criteria. All this means is that there are these 4 basic rules, and if the entire number value, if the digits follow these rules, then those digits are significant digits. So, if the digit is not equal to 0, then it is a significant digit. But even if it is 0, if it's between significant digits, it counts as a significant digit. And all digits that are recorded after the decimal point are significant only if the number before the decimal point is not 0. So if the digit before it is 0, but the number before it is 10, it still counts as being as a significant digit. So with this example, like 10.0 and 0.01000, for the first one, 10.00, there's 4, and for the second one, 0.1000, there is also 4 significant digits. But the 0.0 does not count because they are zeros. The number before the decimal point was not 0, and the 0 right after the decimal point wasn't trapped in between significant digits. So, sample problems. How many significant digits are there? For the first one, there's 2. The second one, there's 2 because the 0.0 doesn't count because it's not between significant digits. And I would ask you to pause so you can do the rest on your own. Now, moving on to scientific notation. Sometimes you will see numbers in scientific notation, like 1 times 10 to the power of 2. What is scientific notation? If the number follows these rules, then it is scientific notation. The coefficient, that number before the multiplication sign, it must be equal to or greater than or less than 10, which means it must be between 1 and 10, including 1. The base, which is the number that you add the exponent to, must be 10. And the exponent is not 0. If the number follows all these, then it is scientific notation. Now, more sample problems related or about scientific notation. So, like the first one, how you count significant digits in scientific notation. So for the first one, there is 2 significant digits because there's just 2.6. The times 10 to the power of 4 does not count as significant digits. So first one, 2. Second one, 2. Third one is not scientific notation, but there's 4 significant digits in it anyways. The next one has 2. But the next one is not valid because if you recall, the coefficient, which in here is 12.03, the coefficient must be between 1 and 10, including 1. So this is not a valid value, and this is not significant, and this is not scientific notation. Moving on is 3, again invalid, 3, 3, and 1. Now, for operations, things get a little bit more difficult. In operations, significant digits are used to simplify an answer to a relevant accuracy. When using significant digits to round, there are 5 rules. Round only at the end of the problem. When rounding, round according to your final place value. So only the place value that you're using, and round using the digit after that, the value after that. When adding or subtracting, round to the lowest number of decimal places, not significant digits, decimal places. When multiplying or dividing, round to the lowest number of significant digits, regardless of decimal points. Now, more sample problems. First, you need to do the equation, and then you need to round it. So in the first one, 21.03 divided by 3 becomes 7.01, is rounded down to 7. Next one is scientific notation, so it stays exactly the same. Now, more sample problems, focusing more on multiple operations. So for the first one, lowest number of significant digits was 2. So you got 72. Probably was stripped to 72 or something. Now you see in question 9 how 1 million times 2, the lowest number of significant digits is 1. So you need to keep it at 1. Thanks for watching. Hope this helped.